So something we can do is multiply two values that are in scientific notation. And something we're going to need to use for that is a rule of exponents. So what this rule says is that if you have a base with some exponent, multiplying with something of the same base, which is very important that those have the same base to them, and it has some exponent. Now those values can be the same, they can be different, one can be positive, one can be negative. There's no rules really for those exponents there. But what is important that we're multiplying two things with the same base in this exponential form. Then what we can do is combine them so that it's just that same base. And what you do to the exponents is you add them together. You take that first exponent plus the second exponent. So what this does is it allows us to take two pieces that are multiplying together and change it into a single term. So if you had like x cubed times x squared, what you could do is combine that so that you just have that same base x. And then for the exponent, you would take 3 plus 2, which is x to the fifth. Which makes sense if you wrote it out like x cubed times x squared. Well, x cubed is just x times x times x. And then x squared is x times x. Well, if you're multiplying those together, then really you just have that same thing, that same value of x multiplying to itself 5 total times. So if we had 10 cubed times 10 squared, then what we can do is combine those together so that it's base 10, and then 3 plus 2, which would give us 10 to the fifth. So this will let us combine two pieces together. So let's see how we can carry that out. And with these, we're going to end by writing them in decimal form. So what we're going to do is kind of think of pairings here. In terms of multiplying, we're going to multiply that 4 and 2 together. So we're going to have 4 times 2. And then you can use the x as the separator. I mean, really, this is just a big string of multiplication. This is 4 times 10 to the fifth times 2 times 10 to the negative seventh. So really you just have 4 things multiplying together. What's going to help is separating it in terms of multiplying those two numbers and then times multiplying our exponential pieces with base 10. So 10 to the fifth times 10 to the negative seventh. So this is where I'm kind of separating it into that 4 times 2, and then we have that multiplication, and then this 10 to the fifth times 10 to negative 7. So 4 times 2 is just equal to 8, and then times, and here's where we're going to use that exponent rule. So we can combine these to a single base 10, and then we're going to add the exponents. So 5 plus a negative 7. So 5 plus negative 7, or you could think of that as 5 minus 7. So that's going to give us 8 times 10 to the negative 2 power. Now this is our answer in scientific notation. They want it in decimal form. So if we think of having 8 with our decimal place, and then our scientific notation's telling us to move left 2. So I'm going to go 1, 2. So in decimal form, my final answer would be 0.08. You can have that 0 up front. So there's solutions in 2 forms here. This would be our solution in scientific notation. Here's our solution in decimal form. All right. Let's do this next one. Again, I'm going to think of it in 2 pieces, the 3 times 2 and the 10 to the 6th times 10 to the negative 8. So I'm going to have 3 times 2 on one side, and then times 10 to the 6th times 10 to the negative 8. So 3 times 2 is 6, times 10 to the 6 plus negative 8. Which will give us 6 times 10 to the 6 minus 8, so that'll be negative 2. So in terms of decimal form, if I have 6, we're going to move to the left 2 spots. So that will be a 0.06 in decimal form. All right. right, and our last one over here. So we're going to have 3 times 5, and then 10 to the negative 2 times 10 to the negative 1. So 3 times 5 times 10 to the negative 2 times 10 to the negative 1. So 3 times 5 is 15, and then we'll have times 10 to the negative 2 plus negative 1. So this will be 15 times 10 to the negative 3. So in terms of decimal form, we'll have 15, and then we're moving to the left 3 spot. So I'm going to go 1, 2, 3 for a 0.015 in decimal form. So with those first 2 questions, we had solutions in both scientific notation and decimal. Same thing for the second one. Notice with this one, so we definitely have our answer in decimal form. However, this piece right here is not scientific notation. It looks like it, but there's one little piece that's wrong with it, and it's coming from that 15. Remember, that number has to be between 1 and 10, so 15 is way too big. So this is something we need to pay attention to, because sometimes we'll be doing these calculations, and if we're asked for our solution in scientific notation, which is what we're going to be doing next, we need to make an adjustment. So to show you what that adjustment will look like, if we have this 15 times 10 to the negative 3, and what can help is if the exponents aren't too big, it can be helpful to see this format here in decimal form, because the idea is going to be my decimal is right there for 15. I need to adjust that so that I'm actually dealing with 1.5 and then times 10. But what I need to do now is adjust my exponent, because in the end I should still have this same decimal here. So what we did was, by bumping our decimal over there, now I'm starting here. So all I would need to do is go 1, 2. Now I would just need to move my decimal 2 spots instead of 3 spots. So what's happening over here is, by moving the decimal over, where I would have negative 3 before, what we do is we add 1. So with this number here, because I moved to the left 1 spot, I added 1, which I know is confusing because it's basically opposite of what we've been doing this whole time, but it makes up for this fact that we're actually closer there. So we don't have to move 3 spots. Now we just need to move 2 spots. So in the end, seeing the decimal form really helps. So what we would do is, to have the scientific notation for this answer, this would be our scientific notation. Having 1.5 instead of 15 corrects that piece, and then adjusting our exponent so it works together with 1.5 instead of 15, which will often come through as a +1 right there. So let's try that out with these examples down here. So we're going to have 6 times 3 times 10 to the negative 2 times 10 to the 8th power. So 6 times 3 is 18 times 10 to the negative 2 plus 8. So we're adding those exponents together. So this is 18 times 10 to the 6th power. But I need to pay attention to the fact that this 18 is too big. So what I need to do is take where that decimal is and move it so I'm actually dealing with a 1.8. But by making that value smaller, I need to change that to a +1. And if it helps, again, to think of the decimal form. So if we have 18, and then this is telling me to move the decimal to the right 6 spots, I would go 1, 2, 3, 4, 5, 6. So this is the decimal form of my answer. So starting there and going 3, 6, that would give us the correct value. Now I'm saying I need to be at 1.8, which means that decimal needs to travel 1 space further. I would have 1, 2, 3, 4, 5, 6, 7 now. So 7 versus 6. So with this, I would write 1.8 times 10 to the 7th power. And that would be correct scientific notation because that 1.8 is now between 1 and 10. All right, over here, we're going to have 1.26 times 3.21 times 10 to the 4th times 10 to the 5th. Now this 1.26 times 3.21, if we plug that into a calculator, we just need to grab some decimals there. So I'm going to grab this 4.0446 from the calculator, and then we're going to have times 10, and then for the exponent, 4 plus 5, which is 9. And then I just kind of check through, okay, that number is actually between 1 and 10. So that's all done, which means I don't need to adjust that power of 10. So this is all set. Just sometimes you might get a messy decimal there. Maybe they'll give you some rounding information. This, I didn't provide any rounding instructions, so just write down as much as you can and include all of the values without rounding when possible. All right, with this one, so we're going to have 5.8 times 3.2 times 10 to the 5th. And if you want to, you can go ahead and skip a step here. If you know you're going to be adding those exponents together, this will be 10 to the 5 plus negative 9. All right, 5.8 times 3.2 in a calculator will give us 18.56. And then times 10 to the 5 plus a negative 9 will give us a negative 4. But 18.56 is too big, so I need to move my decimal over to make a smaller number, which means we're going to add 1 to the exponent there. So this is going to be a 1.856 times 10 to the negative 3. Again, if it helps, what we could do is look at this in decimal form first. So if I have 18.56, and this is telling me to move to the left 4 spot, so I'd go 1, 2, 3, 4. So really I'm looking at this 0.001856. So if I change this to 1.856, I want to move to the left 3 spots. I don't want to have as far to travel. 2, 3. So I still get those 2 zeros and then the 1856. So these calculate the same thing, which is good to double check when you're just adding 1 up there and moving a decimal over here.